Okay, so the homework, project number 1 is going to be due Tuesday, April 21st. It's pretty straightforward. It's going to be really an application of what you've done so far. It's going to be basically going to be choosing a data set, and you're sort of like what you did with the homework before last, assignment 4, and what you did with the Harvard data set, of really exploring a data set and communicating a data set visually, as well as the statistics on the data set. So really, the project in this class is intended for you to have as much latitude, as much freedom to really explore and to really take advantage of what you want to learn in this class. And so when you approach this project, really, in order for you to get the most out of it, you should really invest the time and the effort to really find something you're interested in, and really, really find something that you'll want to, that you're curious about. It should pique a sense of intellectual curiosity about you, and there's tons of data sets out there. So, I won't, read through all the instructions, but this is here in the DAT 20 NYC folder. I also want to highlight in the resources folder, there are tons and tons and tons of links on online classes, on all sorts of stuff in the community, sources of data sets, blogs, aggregators, and so forth. So you'll be, as a first step, initial step, you'll be really finding a data set that interests you, and exploring it and sort of formulating a hypothesis, basically trying to explore and find something interesting trends, interesting features in the data, just like we have with the bike share data set. I also want to mention there's one of the best sites, and I always check Kaggle when sort of coming up with material for this class. Kaggle is basically a site, sort of almost like a GitHub for data. It's really a community, a collaborative, competitive forum community for solving certain challenges and certain competitions. And so they have all sorts of interesting stuff. Some of them are more difficult than others. Some of them, are sort of covered or require tool sets that we haven't yet covered in this class. But it's worth exploring this stuff. For instance, you can even see the bike sharing here. It's worth exploring this stuff because people have posted whenever there's a popular Kaggle competition. Oftentimes there's blog posts about it. Oftentimes, it gets there's GitHub repositories, and there's papers written, and there's lectures, and so. I would start here. I would start at Kaggle from a first place of really finding something that interests you, from there I would also just look through each of the links in the resources folder. So really the first thing you'll be doing is, again, just find a data set and explore it, find something interesting about it. Questions on that?
Are there entry-level ones on Kaggle?
Yes. They aren't really categorized per se in terms of easy, medium, hard, but one thing you can do to sort of filter it is you can sort by, sometimes there's, the rewards will be proportional to the difficulty. How many submissions there are. They're not. I mean, it's sort of subjective what's easy and what's difficult, but there are definitely some that are more different than others. So yeah, make sure that before you dive into a data set, before you sort of like get too deep in the weeds of solving a data problem, make sure that the data set makes sense and it's something that's interesting to you and something you want to solve, and just understand really how it fits into the context of what we're learning in this class. For instance, some of these like Digit Recognizer and Million Song data set. Those involve signal processing and so forth that we don't really cover in depth in this class. And you can apply the stuff that we've learned in this class to those data sets, but it's probably going to be more challenging. Data sets I recommend are the Titanic data set. This data set we'll actually be covering today in class a little bit. It's an interesting data set. It just looks at the certain statistics on who survived and who didn't in the Titanic disaster. As well as like certain social classes, their gender, their age, and so forth. Other ones, some of these are also for interviews, or they're used as a means of recruiting. So if that's something you're interested in, the recruiting, the projects in here that are focused on recruiting have a category of jobs, and they're usually more narrow in scope. The ones that are more broad in scope, usually have a higher reward, although that's not necessarily the case. Sometimes they're just interesting problems to solve. They're trying to solve they're trying to get the most amount of entries possible, and so they'll increase the reward. It doesn't necessarily mean that it might be more difficult to get a very, very high performing score on it, but it doesn't necessarily mean that it's a difficult data set to mine. In any case, it's worth exploring this stuff, and at least getting a sense of what's out there and sort of the approaches that people take to solving these problems.
My second half of that was I always found money to be a good incentive, but I'm probably not going to
It's probably not going to happen, but maybe.
Are there places where, I don't know, are there areas of emails.com where people will pay you $100 to clean up a data set or to
Probably. I mean, there might be. Probably not. Probably not. That would be suitable for this particular class, because if you want something to be done reliably, like cleaning a data set, unless there's sort of two approaches. Either you have someone go line by line through the code. So there's, usually when companies want a data set cleaned with some sort of human input, they'll use a tool like Amazon Mechanical Turk or something like where there's, relatively low cost, but sort of menial labor. When you need when it comes to a sophisticated, data cleansing and data reshaping, it's usually not stuff that companies will even outsource sort of at a low cost. So not that I know of. There isn't really an Elance or something for cleaning data sets. Okay, let me just remove some of these old recordings so I don't run out of. These things reach 8 gigabytes each, and I don't want to run out of room on my disk. So this lecture, we're going to be spending most of our lecture today consolidating everything we've learned up until now, putting it into practice. In particular, we'll be going in more depth on the bike share data set. And we're just going to work through really, last two homeworks, sort of start to finish, and just sort of understand the nuances, understand the flow of what it's like to really work with a data set. The interesting thing about the bike share data set, and again, it was actually gotten from, I got the data set from Kaggle. But the interesting thing about that data set is that it is a real data set. It's not an artificial toy data set. Some of the UCI data sets and similar data sets we were talking about earlier in the class were sort of contrived or cherry-picked or heavily filtered to solve a particular type of problem, where they were used for demonstration purposes. And what's interesting about the bike share data set, and again, this is sort of in the theme of talking about Kaggle, is that a lot of people who have looked at this data set have come up with different methods, different techniques of forecasting, and really solving the problem that you were doing for assignment 5, last assignment. So, linear regression is probably the lowest hanging fruit, but people have come up with all sorts of clever methods of mining this data set, and you can read the forum on this data set, and I would really urge you to just on your own time go through this stuff, because there's interesting discussions, there's interesting problems that people have solved, and you'll likely find people have tried maybe similar solutions, similar approaches to what we took on last week. And there's actually some interesting blog articles which I'll send out as additional resources after this class. Anyhow, make sure you pull the latest. I did update the class repository today, so make sure you're on the latest commit on the GitHub repository. By the way, if you do git log, you can always check the most recent commit. If you just look at this git SHA, if you're just curious on if you're not up to date, when you do a git pull, it'll get you up to date. It'll automatically synchronize and get you up to date, but 14 minutes ago, commit F5 FF071. So this git SHA is basically just the signature. It's the first, 6 digits of the git SHA. So anyhow, pull that down, and we're on lecture 9, I think. Class is going quickly. Lecture 9, model evaluation. Oh, excuse me, I haven't. I actually have it in drafts. I need to post that on the repository right now. Share review, model evaluation. Can you guys see the screen okay, by the way? Do you want to? Yeah, thanks. Yeah, something's wonky with the lights. Okay, so correction, I just posted. I had the bike share review in a folder not being tracked by the Git repository. So pull that down, and the IPython notebook is bike share review. Actually, in the interest of getting everyone on the same page, let's start a IPython notebook from scratch. And I'll just restart my IPython notebook. As soon as IPython shuts down. Guys in the back, you can see the text okay? Let me know. I'm just going to close bike share review in class. Okay, and again, sort of the usual suspects, import pandas as PD, import numpy, SMP. And we'll start, I guess we'll start with the basics. Just matplotlib, inline, sort of familiar stuff we've done so far. lib.pyplot.spt. Okay, so I'm in, right now I'm, I guess relative to the data folder, I believe I am 2 folders up. Yeah. And again, this stuff is all stuff familiar to you by now. Just going to read the CSV from the URL. If you followed the example I posted yesterday online, there are some columns in here that are clearly more interesting than others. But when we look at a data set, we don't necessarily know which features are going to be most powerful, most interesting. But clearly here, instant is just really just the index. I can throw that away. So I'll just basically discard. But by the way, usually by convention, this is just sort of my preference, but usually when I will keep the original data frame that I load in a variable, usually with an underscore CSV as a suffix. So that way I can just get back to it. If I want to modify this, I can basically, for instance, when I drop my columns, like let's say I want to drop the instant column, say axis equals 1. I want to at least, I don't want to at least modify the original data set, unless there's a reason to do so. Like I care about if it's a massive data set and I want to conserve memory. I might overwrite the original rather than keeping the copy around. But I'm just going to drop the axes, and just when I apply each step of the cleaning, I'm usually overriding some variable. So let's see, what else can we remove? I think for now we'll remove date, day, as well the date. And I mentioned just sort of shorten this. I mentioned the importance of previewing your data set. Just make sure that the shape and you know the types of values in the columns all make sense. Make sure that you also do, there's a pandas attribute called dtypes, short for data types. And you want to inspect that as well. For instance, if any of these variables were, say, like a string, it's not necessarily obvious just previewing a data set with .head command. It's not obvious what these data types are, and so we just want to make sure that our column types are all as we expect. In this case, they clearly are. So season, all my variables, all my columns are numeric, which is actually kind of nice because it makes things easier. Weather sit, however, is a categorical variable, and it's mapped to an integer, even though it doesn't really have, you know, a well-defined numerical value. So we'll deal with that one separately, but you know, just sort of inspecting and glancing over the types of my columns makes sense to me, right? Season, year, month, hour, holiday, weekday, working day, et cetera, et cetera. Those are all numerical values, and clearly they're cast properly. Continuous values like temperature, adjusted temperature, humidity, and wind speed are all as I expect them. And in the interest of keeping my workbook sort of short, you can press, I think it's Shift M. If you're not in edit mode, you can press Shift M, and it will automatically concatenate the cells. So as I go, you know, sometimes you'll have sort of this issue where you get all these cells and it's sort of awkward and clunky and you're having to like navigate around. I collapse my cells every so often so I don't have like all these sort of like stringy, granular cells to interact with. You can also press O. Sometimes I want to toggle the output. Just toggling O in edit mode will help toggle the output. So I'm just going to collapse that. Maybe we'll come back to it later, but you know, it's not, that output isn't particularly interesting so far. And you can double press DD to delete all these. So I'll just delete all these. It'll really be a huge time saver the more you familiarize yourself with the IPython hotkeys, because it's sort of clunky to interact with. I mean, it's a web view, and it's the more you when you use the hotkeys, you'll exponentially increase your productivity within your workbook, within your workflow. And I can get rid of these as well. Okay, so we have our data set, and I guess I'll pull up the requirements of the assignment. I'm not going to follow the assignment exactly. We're actually going to sort of go beyond what was required in the assignment. But just in the interest of getting everyone on the same page, really there was a few key questions. We were really trying to read the data set, split it into two equal-sized halves, and build a regression on the first half and evaluate the regression on the second half. And there's a few interesting sort of quirks. For instance, adjusted temperature and temperature were correlated. But let's start by, you know, in the spirit of what we did last class, let's start with just looking at the summary statistics. So we bike.describe, bike share, describe. So we have 17,379 observations. I think this is the largest data set we've looked at so far. And it goes over 2 years. So again, we'll toggle this output. And I'll just sort of like inspect the bike share, do pd.scatter matrix. Just sort of see what the distributions look like, what the general trend of the data looks like. pd.scatter matrix. And this is going to be actually pretty small because I think there's a lot. There's how many columns? I think there's 17 columns, 14 columns. It'll take a while to run. Anyhow, there's sort of two visual approaches that you should generally apply off the bat when visualizing a data set. First is scatter matrix, but also I forgot to do matplotlib inline. I'm going to squelch the output by putting a semicolon at the end. So you get this verbose output if you don't have the semicolon, and sometimes it's just annoying. Go figure. So in addition to scattering matrix, I recommend you just plot a histogram, and that'll basically plot a histogram for each axis. So we call it just .hist on a data frame. It'll plot a histogram on the axis. As soon as it runs. So yeah, it's a little bit dense, a little bit more information than I need, but clearly there's some interesting trends in the data. We've looked at this before. Some features are more interesting than others. Obviously, temperature and atemperature are highly correlated. One thing that I notice, I'll sort of zoom in here. It's a little bit difficult to see. See how there's looks like there's some mislabeled or some misclassified values. I have a set, if I look at temperature and atemperature, there's something going on here that doesn't make sense. So look for where there's outliers in your data. Look for where there's things that don't make sense. There's a lot of overplotting going on, and so we would use alpha to sort of reduce the complexity, if we really want to visualize this data. But what's also interesting is that if we look at the number of registered users and the number of casual users, sort of has this sort of heart shape. It's not symmetric. Some of these other features are a little more, I guess, they're irregularly shaped, but they're not necessarily split like this. Why? So why does this have this shape? What's going on? I mentioned a couple classes ago that sometimes we'll see, especially this is really what's interesting is this is in the context of the assignment. This was our target variable, right? We're trying to predict the entire purpose. The hypothesis that we're trying to solve. The problem that we're trying to solve is modeling and estimating and understanding count as a relationship of all these other variables. And this isn't a coincidence. It's not just happening for no reason. There's a reason that this is happening. What's happening?
The answer isn't that impossible word to say, right?
No, it's pretty much one word. Now, remember, this is the number of we're looking at the number of bikes usages per day. So we're really over time we're looking at the number of bikes that are used, I guess shared, per day over 2 years.
So the number of registered users went up year over year, so then it was the skew and you correlate the casual which stayed a little bit flatter.
Yeah, it's actually, we're sort of seeing a bimodal distribution because, well, first of all, there's seasonal trends. So we're going to see some fluctuation in our usage on a season by season basis. But we're also seeing a fluctuation in usage on a seasonal basis as well. And that's sort of what's going on here. You see this sort of almost like a sinusoid. What is this? This is temperature is a function of hour, right? So I guess like that's not surprising. But you see also per month, so you're seeing some seasonal trends in the data, and we don't want to how that might have some influence in a model, but it might also have some influence on a model that we don't expect. And we'll evaluate by the time we're done with this exercise. We'll have sort of seen a way of evaluating and sort of eliminating noise or crappy columns from our data. Shrink this down a little bit. So yeah, I mean, you sort of see that in the histogram. I'm not going to spend too much time talking about the visualization, but we also, really the first thing the homework asked you to do was to split the data. And some of you applied a variety of techniques to split the data. Some of you guys used scikit-learn and used train test split. And that's fine, but one of the things at least I wanted to show in this data set was there's a reason why you picked the first half and the second half, and it has to do with that split in the data between if you're talking about the data is chronologically ordered, and so because it's chronologically ordered, there might be certain assumptions that are valid in the first set of data that don't necessarily hold in the second half of the data. You were also asked to calculate a column called rush hour. I'm going to do that first. Before I split my data set, I want to perform all the transformations that I want to apply to both splits first before I do the split. Because if I split the data, then I want to make sure that the data is consistent in both sections. So we're sort of we'll come to this later. We'll say this is part 3, split the data. Should call this part 4. Right, so part 4 split the data. Part 3 we'll say is perform calculations. Part 2 we'll say was describe and summarize the data. Describe, visualize, summarize. That's a nice ring to it. And part 1 was really just importing the data. Trivial in this case, but depending on where the data is coming from, it may not be trivial. If it's coming from some online or some online source or some data source, there might be more credentials, etc. Loading, fetching the data. So far, so good. But one section of the homework asks you to calculate the rush hour. And there's actually a reason for that, which we'll see in a bit. But what was the range for rush hour? It was between what and what?
It was 6 and 9 in the morning.
6 and 9 and 4 to 6 p.m. And one of my columns in here, so just sort of, also one thing which I sort of missed or forgot to do, I always like to, if there's a description for the data set, if there's a description for the data set, I usually copy and paste it. Just so I can cross-reference it, so I'm not having to constantly navigate to this stuff. And there's a data set description, which I think is right here. Just so we can access that information whenever. I'll just paste it up here. And comment it out. So we want to basically first filter, or at least perform a calculation on a single column of data and add an additional column, which we call a calculated column. So if I look at bike share hour, there's a column called hour. And that's just the hour of the day, obviously, between 0 and 24. If I want to look at sometimes I might want to look at the sense of, obviously they're not all going to be unique. They're only going to range between 0 and 24. I can call a method called value counts. And again, what type is this? So type bike share. Bike share is a data frame. When I select a single column from a data frame, however, I get something different. I get a series, which is just a one-dimensional data frame. And they actually have a very similar interface. They have the same sort of behavior, but value counts, I can only call value counts on a single column. In other words, a series of the data frames. So just something to keep in mind. When you select a single column, it returns a series. But if I try to query multiple columns, we'll return a data frame instead. So series is just a one-dimensional data frame. Okay, so I've seen hour counts, nothing surprising, and it ranges between 0 and 24. And I want to say any number, and let's say I'll do sort index, because it's annoying, so I can sort of... By the way, there's sort and there's sort index. The index is really the name of the rows, and it's usually an ordered list. But I want to say assign anything that has, I guess, 6, 7, 8, and 9, and between 4 and 6. I want to perform a calculation on that. So if I say bike share hour, and this is what we call logical indexing or Boolean indexing, I can perform calculations on that data. So I can say bike share 6 is true, or bike share hour equals 6, and we get basically, this is what we call a logical vector, or sometimes called a Boolean or a binary vector back. And I can say bike share, if I do bike share, and I can access, I can address bike share based on a logical index, and it's just going to return a subset of that data frame. It's going to return a subset of that data frame that matches that logical index. And so again, you can imagine I can sort of go to town with this, and I get a bunch of 6s back, unsurprisingly. But I don't just want bike share where the hour is equal to 6. I want bike share where the hour is greater than or equal to 6, and it's less than or equal to 6 and 9. So we can say hour is bounded by 6 a.m. and 9 a.m. inclusive. And again, just like I did previously, I can index that and get some subset of bike share back. I need to wrap this, and it'll get finicky. So this ampersand, this single ampersand, is what we call a logical AND, and it's distinct from the binary AND, and it's distinct from the logical AND. Just to sort of show you the difference, if I have two lists, say 1, 0, 0, and I AND it with 0, 0, 1, I'll get back a 0 vector of length 3. If I have a vector of all 1s, and I evaluate it, then it's going, the ampersand, then, and by the way, this is something that's sort of comes packaged with NumPy and pandas. Anyhow, when I do an ampersand on that data, it'll give me all zeros. When I do an OR, what do you think I'll get back with an OR? Yeah, let's go to 1, 0, 1. Straightforward, right? I mean, it's basically just applying an OR and an AND. It's doing it element-wise. So I want to say bike share where the hour is greater than 6 a.m., less than or equal to 6 a.m., greater than or equal to 6 a.m., less than or equal to 9 a.m. That's my inner statement. My outer statement is telling pandas to index, to subset bike share on those values. So I'm going to say bike share hour is greater than or equal to 6, and bike share hour is less than or equal to 9, and I'm going to apply an OR, and then what am I going to put here? By the way, you guys should be following along, but I'll let you guys sort of finish out the next clause. It's pretty straightforward. Give you guys a few seconds just to sort of catch up, and myself catch my breath, and let you guys basically build out the index so that I'm only returning values in bike share that are between 6 a.m. and 9 a.m. and 4 p.m. and 6 p.m. And by the way, I have to put these in parentheses. Python will complain because it's kind of ambiguous. It's not sure if I want to do 6 ampersand this. So it just wants to see, I should be explicit on order of operations that I need to group this first clause. And I need to, you just basically let them know to evaluate, let pandas know to evaluate this inner statement first, and then the outer statement. So it's really 2 clauses here, and I just cut and paste. Cut and paste, and it's really just changing a single variable, right? I mean, so what I get back is just an array of values that are true or false. Just a logical index. And it's the same length as my original vector. And so I'm just using that to really filter, to break down values of bike share that I want. Actually, excuse me. So these are in a Boolean form, a binary format. They're true and false. I want them to be 0 and 1. How do I get them to be 0 and 1? Because I don't want. It's easier for me to do certain analyses, certain computations on true and false values than it is to do. Sorry, on 0 and 1 values than it is to do on true and false values. And I can just basically convert. If I have a series, I can just do as type, and I'm just going to be explicit and call this a integer type, numpy.int. What do I get? Just get 0 and 1. Cool. Cool. So now basically all my work is done for me. Do bike share.rush hour and just assign it directly. So I'm doing basically again just this is what we call a calculated or a generated column. I don't have rush hour in my data frame yet. I'm just adding it. So I'm doing both the calculation for true and false here, and I'm assigning it to bike share rush hour. And now if we do bike share.head, blah, 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 we can see that there's now this calculated rush hour column. So just like we removed columns we didn't want, sometimes we're sort of engineering and designing columns that we maybe do want. And we call this, as a term for it, we call this feature engineering. I'll write it on the board because it's worth writing on the board. Because we're going to see this multiple times, but sometimes we want to calculate and use the data we have to generate new data via some calculation. We're not actually adding information by doing this. We're just sort of representing the data, in maybe a different way, so that our training algorithm, our model, maybe responds well to certain values and certain features. So just like we remove features from our data set, sometimes we will modify and perform computations on features, and scale them and transform them in order to allow our models, allow our computations to be more effective.
Yeah, then why do we need the pipe between the first 2 conditions and the second 2 conditions?
If you were to read this from left to right as a sentence, what would it be saying?
You'd say this and this and this and this.
Well, most of the way, you're mostly correct. I can sort of read this like a sentence, right? This part, if I read this part just as in plain English, I'm saying bike share, basically hours between 6 p.m. and 9 p.m. I'm calculating values where it's true if it's between 6 a.m. and 9 a.m. I'm saying this is bike share between 4 p.m. and 6 p.m. This is just or, so I'm just saying
So instead of the pipe, you could actually put or.
I don't think you can put or. Try it, see what happens.
Yeah. Doesn't work.
There's a difference.
Does Python order of operations always put ands before ors?
It should, yeah. They have a higher precedence, so as far as I know, they should always be before. Yeah, so I mean, logical binary Boolean algebra follows the same standard order of operations as Boolean algebra. The reason why I had to put parentheses, around this part is because, it doesn't necessarily know, which one to and. It might try to convert this to a binary and and it. Cool stuff. So I have rush hour. I have, I've filtered my data set, removed some meaningless values, added some hopefully interesting ones. Let's move on to the fun stuff. Let's start sort of seeing what relationships we can find quantitatively. Let's perform some mining, some modeling on this data. So sometimes, by the way, this isn't necessarily the only way of doing this. In pandas and in programming in general, there's oftentimes more than one way of going about something. I found this way to be the most concise. It's a little bit awkward because there's a lot going on in this one line of code, and usually when you have, if your lines are long like this, it's just hard to read. So, I might say something like, rush hours, and assign it here, and then just so I'm at least communicating good style, I might just do something like this, and then break it down into a series of steps. I'm not going to worry about it too much right now in the interest of time, but it's just something to keep in mind. And now I'm ready, now that I have the bike share data, I want to split it in half. Right? So I have some bike share data that has a certain number of rows. What variable do we use to indicate the number of rows? And what variable do we use to indicate the number of columns by convention? I just kind of showed you, didn't I? I can say columns. I can say columns.length. I could do this. But there's actually sort of a cleaner way of doing it. I can say bikeshare.shape. And you should always, just like you're inspecting, just like you're keeping an eye on the types of your data, just like you're keeping an eye on certain outliers or certain certain missing points in your data, you always want to be making sure that the types and the shape and all this stuff is what you expect it to be. So if I say bikeshare.shape, this is in the convention of rows and columns. And so there's 17,379 rows and 16 columns. I can just do this. I don't even need the parentheses. Python's kind of cool like that. It's what we call syntactic sugar. I'm basically just assigning, in a single line of code, I'm assigning both n and m. Because shape returns a tuple, it'll automatically match the elements of that tuple to the assignment on the left-hand value of the assignment. By the way, the difference between a tuple and an array, they're almost sort of the same thing. Tuples are of fixed length, so whenever I have values or certain values that I don't want, if I have a collection and I don't want the size of that collection to change, I can use a tuple. By the way, I forgot to do something important. In this case, it doesn't necessarily matter, but I might want to drop NAs here as well. And so just like I called drop, I'm going to call it here. I'm just going to drop NAs. And I don't think it actually changes in this case. I don't think there's actually any NAs in this data. And there isn't. So by the way, when using IPython, I like to be able to run cells multiple times. If I say do a calculation in a cell and I can't run it multiple times, I think it's kind of messy and it becomes hard to work with that notebook over time. You've probably encountered, you all in doing these homeworks have probably encountered issues where you do a certain calculation, right? So if I reassign, if I say split my cell, you can press Shift Control Dash, I think, to split a cell. So if I say bike share dot-drop, and I run it multiple times, then I start getting errors because I'm trying to drop columns that it'll run once, but only run once. And it's just a pain to deal with this stuff. So yeah, in the spirit of teaching best practices, it's just something that'll save you time. And that's why I use a different naming convention. Okay, back to the task at hand. I'm going to call these capital N and capital M. I have n data points, and so how do I split data share? Sorry, bike share. How do I split it by 50%? I want 50% of my rows in one data set and 50% of my rows in another data set.
Use the IX method.
You can use IX.
I just look like had
You can use, so something that you should be familiar with is how to index a data frame. So if I do this, I get all the rows, right? So I get all the rows, I've done this before. If I want to say subselect some subset of those, these, by the way, these operations are what goes in the brackets here is not necessarily, it's going to depend on your index values. But I can say I want to select the first 10 rows of the hour column, and I get that back. Alternatively, I can do bike share, and I recommend, so what's actually doing, when I chain commands like this, and you guys have probably seen this sort of copy warning that comes up. When I chain commands like this, what I'm doing is I'm actually doing two operations. It's as if I'm doing, it depends on the version of Pandas. It's not always explicit how this happens, but I can basically do, it's as if I did this, dot copy, and then did this. So it's actually doing two operations. It's not doing one operation, and it's going to be there's a little bit of performance penalty when you do this style of indexing. Sort of the pattern to get around that is to use the .loc function, and it basically, the syntax is, and it has this sort of bracket notation, it's rows and calls. So if I want to basically just look at bike share, and if I want to do the same exact calculation that I just did, let's say the hour, and let's do the first 10 rows. Oops. Not the other way around, sorry. Calls would be hour. So calls, if I do first 10 rows, yeah, I have to call the method, thank you. So if I look at the first 10 rows and just select hours, I get the same thing back. But it's actually not technically, even though I get the same result, it's not going about it the same way. And it's actually returning a direct reference to the data frame, the original data frame, rather than creating what's called a defensive copy. Some of these methods in Pandas will return most of them will return what's called a defensive copy. So if you do an operation, if you do some calculation, like if I say bike share dot drop, and I drop the hour column, let's say I do it up here. Did it actually drop? Sometimes it will declare, I think with drop it will, I think it has to be axis equals 1. Yeah, so even though I dropped it, technically, this actually returns a value. So even though I've dropped the column, I can really just drop every single column if I wanted to. And then I drop the column and they're gone, obviously, in the value that drop returns. And sometimes if I wanted to actually modify this in place, I would do in place is true. But the reason why it returns a copy by default is so that you don't accidentally mutate your data and corrupt your data frame unintentionally. So something to keep in mind, and I believe I brought this up last time, but sometimes it can have side effects where you think you're dropping or think you're changing the data frame and you're not, and sometimes you'll sort of see a warning indicating that. So just like I selected the first 10 rows of my data, I can just sort of do n over 2. Let's get the first half of my data set. Give this proper syntax, and now I have the first half of my data set. And if I want to do all columns, then I use this sort of, so this colon is sort of saying, in this case it says all columns. In the first case it says basically everything between the 0th row and the n over 2th row. So it's the same thing as saying this. If I can just omit the 0. And
Do you need to have the colon and the columns?
the colon and the column, what do you mean?
Like you have to, can you omit the column?
Well, if I omit the colon, then yeah, I guess so. I actually didn't know that, thanks. So let's call this xtrain. In the let's call this xtrain, and we'll do the same thing on the second half. And again, just very simple. Just get the second half. We'll do xtest. And when you're splitting into training and testing sets, I mentioned this.
You need to make it n over 2 plus 1 for the x test.
Yep. And you'll see why. So xtrain.head, and if I do xtrain.tail and xtest.head, I actually have head is the same thing as tail. You can see I actually have the same data point. I have one data point duplicated in both. So I actually need to do n plus 1. So I'm not including the same value twice.
And that, just because you have
Oops, I had it. Yeah, if I had an even number of rows, I'd be fine. Over 2 plus 1. Getting a truncation error, aren't I? Let's see, n over 2. So if I do print n over 2, I should get 8689, and I do. Yeah, so now they're non-overlapping. I'll clear this out a bit. Press O, press O. And yeah, so I'm basically just going to merge these, press Shift M to merge them. I don't need to have them all split up in very fine-grained amounts. I'll keep the comments here, just for reference. But also, going back to the assignment. Let's see, there was a few target variables which I asked you to find. There's temp, atemp, humidity, working day, hour, and weather situation. We call these what? We call these our features. And I'm going to create just sort of. I want to be consistent. I want to basically make everything in my data as I explore and as I mine this data set. I want to make this as clean and reusable as possible. So I'm just going to basically encapsulate each of these features in an array. And I'm going to say target is count. These are the names of the columns, clearly. And by convention, we call our input vector x. So we'll call this, this is just bike share features, right? And we have some variable y, and that's just our target. Am I missing one? Hour, not an index. It's HR, right? I think that's right. Yeah. Okay, so now X actually has, if I do, N and M, by the way, should be, now that I've changed bike share, now I have to use X, I should use X.shape, right? Because X.shape is not the same thing as bike share.shape. M is the number of features. And here we have 6. And again, I'll just sort of want to, same thing here. I'll just change this to X. So note that I'm sort of, sometimes I'm sort of changing the variable names as I go along, just to sort of keep things consistent with nomenclature. Cool, so I have a training set and I have a testing set. Just do a quick sanity check. I always do head pretty often. If I have Y-train, now I just need to get I have X-train, and I just need to get Y-train. I use by convention an undercase Y because an undercase letter for Y because it's a vector. It's not a matrix. Typically for matrices we use capital letters, capital variable names. For Y, I prefer to use lowercase, just keeping it consistent with the mathematical notation. But it's the same thing here. Y is just bike share target, and so bike share.loc, and we need Y test as well. And it's very important. Sometimes it's always easy to be off by 1 in an index, or it's always easy to when we apply these learning techniques in scikit-learn. Oftentimes you'll find your columns will be the wrong size. You have 2 vectors that are the wrong size, and so it's always good to be proactive and make sure that the sizes and the dimensions of your data frames or your data sets are as you think they are. When it comes to these sorts of analyses, especially when you're doing complex analyses, prevention is always the best cure. And so we just want to make sure that the shape of our data set, the shape of each of these items is consistent. So print this. By the way, let me know if I'm going too fast, if there's like points sometimes I need to slow down. Start by training data set. So X-train and X-test. Cool. So looks good to me. Look good to you?
What was capital X? Was that just bike share?
Capital X is the bike share with just the features. So it's only the data part of the bike share that we're interested in. X is defined right below where I defined. The reason why is because, let's say I want to,
That was just by caps versus lowercase. That's all.
no problem, but you can see that it's easy to add. If I want to add a feature of interest, I can just add it here rather than sort of, it's nice to have all of these sort of separated into their own variables. This makes the analysis a lot nicer. And we have the same thing here, right? So n is actually n over 2. This stuff is all makes sense. Okay. Again, I'll merge these into a single data frame. Sorry, single cell. merge these two, sort of clean things up. All right. Questions so far? So now we're on to the fun stuff. What we've done here, we're calling the pre-model workflow. We're preparing our data, doing all the splits, cleaning it, doing the imputation, doing the calculations, and now we're on to the fun stuff. Scikit-learn. And let's see, from sklearn, import linear model. And keep it simple for now. We'll just import the linear model. And we're interested in a particular module, linear module called linear regression. So I've imported linear model, which is a module, and I've called linear regression, which is just a constructor. It's just basically I'm constructing my linear regression object. And this is, I'm just going to call this linear regressor. I don't want to spoil the fun. What do I need to do? Because this is, probably the most important part, at least certainly the newest material. How do I? What are my next steps here?
Should fit.
Yep. I'm gonna fit on what?
X train and Y train.
Cool. So I have a fit. So I built my model. Pretty easy, right? All this up here, this is like, I don't know, 70, 100 lines of code, 3 lines of code to build the model. And yeah, scikit-learn, obviously there's a lot of magic going on. But even if we did this within scikit-learn, the actual calculation here is probably, you could do this in a few lines of code. So this is what I mean when I say that preparing, wrangling, processing data is, it's definitely not something to be underestimated. So I have a model. So I have linear regression, and what has the model done? So I fit a model to the data, 6 attributes, and so really what the fit has done is it's calculated really just coefficients that pertain to the slope, intercept, and so forth of my model. And I think there's one called intercept. Yeah, there's intercept. Interesting. So we have just like how we plotted, slope and intercept in 2 dimensions on the board. We have a slope and intercept in I guess 6 dimensions. So, maybe a little more abstract to visualize, but still regression nonetheless. And now I have this linear regressor. There's a method in here called score, and I can just basically, it calculates the R squared, and I can calculate the R squared for X train and Y train. I get an R squared of 0.367. How good is that R squared? I mean, subjectively speaking, how good is a 0.367 R squared? It's kind of a crappy R squared. That's a sucky R squared. I think we can do better. But just for fun, let's score this. Again, this is the in-sample score, right? So this is our regression score. This is the sum squared residuals divided by the sum squared total of the mean. It's the ratio of those 2 components subtracted from 1. Again, we just to sort of keep the math clear, this is 1 minus sum squared residual over sum squared total. Let's see how I score on the test. print that out, sort of see the difference. Make this a little larger. Hopefully you guys can see it. Oh my, that's not a very good R-squared, is it? 0.139. Basically, I'm throwing darts at a board. So what do we do, quit? So basically what this is saying is that if I had an R-squared of roughly 0, if there was absolutely no relationship, if I did the worst possible regression, well, I guess not the worst, but if there's a poor relationship between the data, it would probably be for the in-sample data set, it would be close to 0. So what do? How can I improve this? You guys did the homework, so right?
Or we can look at the rush hour.
Yeah, that's interesting. So we calculate this rush hour. Let's see what we get with rush hour. It's rush hour with 1. And this is why I keep this is why I have this sort of vector here. Just so I can, if I want to add, sometimes I want to modify this feature vector, this feature array. And so I just add rush hour, except it gives me an error. What's the error? Rush hour not an index. Oh, wow. Went from 0.36 to 0.50. But our out of sample score, our test set, more than doubled. Holy shit. That's a big difference. We just added one feature and we doubled our score effectively. This is why, sometimes it's useful to remove features. Sometimes adding features also has a huge impact. And logically, conceptually, there's a big difference. I mean, it makes sense because rush hour is a time when there's probably going to be a different number of bikes that are going to be in usage at rush hour. If it's if it's the middle of the day, then it's probably going to be less demand. So it makes sense that count relates to demand.
Did you fix that index?
I reevaluated the cell above because it was referencing an outdated variable. So I just recalculated. I think it hadn't calculated rush hour yet. Yeah, just make sure that this column, that this calculation is here. So we get rush hour. Can I do better? What's another technique? What's another method that I can do to do better?
Remove variables,
Remove variables? Which variables?
things that are already coded.
So ones that are collinear.
Yeah, so atemp and temp is collinear. Although it won't necessarily increase my my regression, or improve my regression. In fact, it's exactly the same, which isn't too surprising. And why is that? Let's make sure we run this again. What happened? Well, so if they're correlated, it might overfit.
The two are that are collinear are correlated to the count, so similar, and it wouldn't affect.
If they're correlated to the count. But don't we already know that some of them are going to be correlated to the count?
Yeah,
Isn't that
but
too?
if you are removing ones that both are correlated, like adjusted temperature, you're removing one of them,
Yeah, it's just basically going to sort of fit one or the other. I mean, hopefully, right? Rather than fit both. Sort of makes sense, yeah. So it didn't really meaningfully change. And you're right, they're both correlated, which sometimes can cause overfitting. Right, so just like we talked about overfitting, when there's overfitting, we're basically fitting in a higher order, fitting terms to higher order interactions, and we're making assumptions that don't generalize to outside of our data set. And when we have correlated, we have variables that are correlated like that, we can often overfit. Not necessarily, in this case it doesn't seem to be an issue, but we can overfit. And so it's a good practice to remove correlated variables. So yeah, atemp is adjusted temp or atemp. Doesn't matter. Let's try, we added a variable, let's try removing some variables, right? So if we have, so write this down, 0.505, 0.279. What if we remove working day? Maybe it's a working day, that has an effect. No difference. Interesting. What if we remove atemp altogether? So let's put working day back. Remove working day altogether. Almost back to where we started. Yeah. Try removing atemp and running the regression again. Again, I'll just sort of make this more explicit. What does it mean if I mean, sort of qualitatively speaking, what does it mean if there's an R squared that's different for our training set and our testing set?
Doesn't generalize very well.
Yeah. And I mean, that's sort of a given, right? Because we've split our data set assuming that, we're looking at past data and future data. So assuming that, there's some period in the past where, if we go back up to our data set, there's some period in the past where there was like, where anything they're consecutively valued and they're ordered by date. So you can imagine, it's almost as if we're looking at a particular instance in the past and saying that everything in the testing set is in the future and everything in the training set is in the past. If we were to shuffle the data set, we would probably get a better regression. But it's just sort of interesting to see how regression or how time series can affect regression when you split the data set, having separate splits. So I'll put atemp back. Any other ideas? So we didn't actually improve. Removing atemp didn't actually help us that much.
So there's some categorical variables here.
There were. And I'll do that sort of quickly. I posted this on Slack yesterday. Weather sit is a categorical variable, isn't it? If I remove it, actually do better. Well, actually not a whole lot better. But I want to encode weather sit basically to be what we call one-hot encoding. So let's apply, do it down here. One-hot encoding. And there's actually more than one way, just like anything else. There's more than one way to do this. But we have a variable. If we look at x, it's weather sit, right? Oh, I moved it. Yeah, have weather set. And let's just sort of look at let's see what it looks like. Value counts. By the way, maybe a better way of doing it is I could just call hist. So it's pretty skewed, which might affect how reliable it is. not very many data points for. Not very many data points for. Was it 4? So I'm guessing 4 is like. If it's 4, it's basically going to be almost a 0 probability that someone's using a city bike. I'm guessing that one's snow. So I'm going to say, I believe that one hot encoding is in the scikit-learn module from sklearn. I think it's in the pre-processing module. I'm going to say import one hot encoder. And let's see, let's do one hot encoder. Clear this, and we'll say OHE dot leave its fit transform. Look familiar? There's a reason, there's not a coincidence that these are all named the same thing. They actually inherit from the same module. But the reason why they have a similar interface is so that, there's consistency. So if an object is interacting with, say, a template object, it can call the same functions and expect to get sort of a similar result. But let's put weathersit in here. Value error. We need more than one value to unpack. I think I need to do this. It's an important distinction between those two things. And it's not an obvious distinction between them. And this is, again, why I keep reiterating why it's important to pay attention to your types. This gives me an error. It's almost the same thing. Because if I looked at these, they would basically give me the same thing. But if I do type x weathersit, they actually give me different things. And this is sort of the awkwardness when working with both pandas and sklearn, is that they're actually different objects. And I mentioned this at the beginning of class. If I do weathersit, it gives me a series. So this is a series object. One hot encoder, if I do this with the 2 brackets, it'll give me a data frame, which, for most intents and purposes, it's going to be function the same thing, but there's certain circumstances where it's not the same thing. And basically what's happening here is that scikit-learn, if I look at the difference between them, is also exists in shape. And this is also why I mentioned the importance of paying attention to the shape of your variables. Subtle difference. See the difference? This is explicitly a matrix with 1 column and 17,379 rows. This is a vector of 1 dimension. So this is 2 dimensions. This is 2-dimensional. This is 1-dimensional. And if I sort of take it one step further and I look at values, what I get back when I look at values is an NumPy ND array. And so there's actually sort of this weird interaction between NumPy, pandas, and scikit-learn. But really the most important thing to remember is that scikit-learn does not actually import pandas anywhere. Scikit-learn is completely agnostic to pandas. It doesn't even know pandas exists. But because pandas acts like, pandas objects, pandas data frames and series act like dictionaries and they act like lists, scikit-learn can interact with them as though they were lists and dictionaries most of the time. Not 100% of the time, but most of the time. And this is one of those exceptions where you have to be careful and you have to pay attention to what you're passing into scikit-learn, because one hot encoder is coming from scikit-learn. And scikit-learn, when I do the fit transform on weathersit, traditionally, it doesn't see it as being sort of like a NumPy object. It doesn't, and it can't perform the calculations that it does. Questions? It's kind of weird. I mean, I guess one of the oddities of these data science packages in Python is that they have to leverage. They try to leverage Python as as well as possible, but Python wasn't necessarily built, from day one to be a data analysis language. It's used for all sorts of stuff. It's a multi-purpose language, and so, because it's a multi-purpose language, it has to make some generalizations. And this is like one of those costs. In the interest of time, of class time, I'm not going to go through the whole one-hot encoded exercise because I posted it on Slack, and you can see it on Slack and go through it on your own. But one thing I want to mention before I continue is that you'll want to pass, in order to get the column, so basically it's encoding it into unique values. You'll need to say sparse equals true if you want to get something that makes sense. I believe it's sparse equals true. Transform order set dot values. Yeah, and so I get 4 values back, and there's 17,379 observations on 4 different values. And reference the notebook I posted on Slack yesterday if you have further questions on this. But when you do regression because you can see that there's some sort of relationship between the weather and number of bikes that are being used, it seems logical to reason as though it would be a variable of interest. Last class we also talked about polynomial regression, and I want to talk about how to do polynomial regression, the process for doing polynomial regression, and the impacts that doing polynomial regression will have on our in-sample and out-of-sample error, because obviously that's a huge impact. Is the degree of our model that we're fitting to our data is going to have a huge influence on whether or not we're overfitting or not. So there's actually sort of this. Just go back up to where I declare x. X.shape is, again, just has the same shape as n by m. There's a particular transform in sklearn, which I'll import here. I believe it's in pre-processing. Sklearn pre-processing import polynomial features. What polynomial features does is it remaps my x vector. So rather than having 6 features, I have more numbers of features to fit my x1, x2, x3 variables. So what I have here is I have a data frame which I've called x, and there's a bunch of features. I think I'm using hour, a tenth, etc. And there are m columns and there are n rows, but I can transform x into additional columns. So I can have one column of my data frame be hour. I can have another column be hour squared. I can have another column be hour times a tenth. And so it's mapping it, so rather than assuming that all of my variables are, all my interactions between variables are independent, maybe there's cases where there are interactions between these variables, and so the regression needs to take that into account sometimes in order to be most accurate. And the problem is that as we increase the as we increase the complexity of our model, first of all, we encounter issues with overfitting, of course. But this size, the length, the width of this matrix, every time I add a polynomial, you can imagine it grows not just x, it grows, I believe, is factorial. If you have, by the binomial theorem, you're actually looking at like n choose m. There's n choose m possibilities. There's n choose m. If I have m factors, if I have m features and p number of a polynomial of order p, then it's proportional to n choose p, number of interactions between terms. basically it blows up. And so every time you increase the number of polynomial, every time you increase the order of your polynomial you're fitting, it's going to very, very rapidly increase the computation time, the computational complexity of your model. In terms of how we build these polynomial features, it's very much like we've done so far. Similar sort of theme, poly features, and I believe in polynomial features I put degree. So I'm going to start with degree 2. If I said polynomial features of degree 1, it would just be exactly, it would do no transformation at all, because I already have degree 1 by default, and I'm going to do, I think it's fit transform on X. Put this in a new cell to sort of clean it up. And let's look at shape. So again, just going to degree 2, as it has now I have 22, I have 28 features when I have a degree of 2, 7 with a degree of 1, right? That's just these, plus 1 for the constant term. There's 1 which is the intercept term. So 6 plus 1, when I go to degree 2, I get 28. So as soon as I start getting a little out of control how many features I'm going to have, you can see it takes a little bit longer. So yeah, I mean, if I'm up to degree 5, then I have a huge matrix. Let's start with degree 2. I'm going to do this modification up here. So in other words, before I start, mapping out X. And I'll just replace X here. And if I'm correct, basically we're first calculating X from bike share features, calculating X and Y, and then we're just fitting that transform. So we're mapping polynomial features, and we're just fitting the transform in X. If I run it multiple times, I have no LOC. Where is that?
So what's actually being stored in X?
Ah, good question. Let's split this. And I'll look at the first 10 rows of X. What's actually being stored, if I just do degree of 1, it's just the original vector. Right, that looks familiar. But if I do a degree of 2, it's basically, for every possible interaction, it's taking hour, and it's taking the element rise of hour times hour when it calculates hour squared. So if I have hour, say it's being between 1 and 24, this is going to be, and let's say I had the temp term, and a temp is 0.12, 0.13, just sort of like making stuff up. Then a temp squared will be 0.144, 0.169, 0.01, and then same thing here, hour times a temp squared. So I'd have some like hour times. So it's just mapping it to all those possible interactions. Oops. Does that make sense? Many orders, it becomes very, very abstract. But you can sort of see, where there's possible interactions. So maybe if I go to degree 2 and then plot this, it sort of gets overwhelming. Yeah, so if I calculate poly features, Did I just something is out of sync. Maybe this will be a good time to take a break. Let's give it